Today's video lesson is going to help you get ready for setting up your resistor lab. So let's do a preview of what we've learned in previous lessons. We've learned about types of circuits, and in every circuit we're going to have setup that looks like this. And there are two things that we have of interest. We have our source here, and this is what provides all our electrons to have their energy, and this here is our load. Now in this particular case, what I've drawn in here is a resistor. And what it does in this case is it converts our electrical energy into anything else. Now there are two ways in which we can wire a circuit. We can either wire it in series or in parallel. So I've drawn here an example of two circuits, or two resistors in series. And over here to the right, I have drawn an example of a circuit with two resistors in parallel. How do we know something's series or something's parallel? Well, what you do is you take your pen and you start at one end of the battery, and you follow your pathway along. If you go through at least two resistors, which I have right here, 1 and 2, without removing your finger, then by definition, those resistors are in series. On the other hand, if we've got our electron and we're forced to make a choice of either going in one direction or the other direction, then that by definition is parallel. Now we also use the analogy about voltage and current being a lot like money, with voltage being represented by money, and current being represented by the number of people that are walking along. So if we've got a typical series circuit like this, with two resistors, and if we say that we get $10 from the bank here, and we spend $4 right here, then how much does this have to be? This one has to be 6 volts. Now let's say right here at this spot, we read this to be equal to 3 people, so 3 amps. Well, if you think about it, all the people from here are going to have to travel along this pathway to the left and go straight up, which means the number of people that are visiting this bank here would have to be 3 people. Then we would continue along, and we'll go back down to the first resistor. How many resistors are going to be visiting this spot? It's going to be 3 amps, or 3 people. So what we can say is that in a series circuit, if we're trying to look at voltage and current, we can see that the voltage adds up if we compare the battery to our 2 resistors, but the current stays the same everywhere. Now if we've got a parallel circuit, which would look something, let's say, like this. Now in this particular case, we've got 2 pathways. So if we say that we're getting 10 volts from the bank here, each electron has 10 volts to spend. So it could go in one of 2 directions. It could go up and across and then go straight down. Now if this is the case, since we know in this whole pathway here, it's only going to have to hit one resistor, we know that the amount spent will be 10 volts. On the other hand, if we've got a resistor and we're taking the outside pathway, well, in this particular case, it's still only going through one resistor. So that means the voltage at this spot here is also 10 volts. Now we've got the black electrons and we've got the green electrons. So if I told you that, let's say in total, that our total current is 3 amps, well, that has to be a combination of green electrons and black electrons. So therefore we need to know a little bit more. So if I say, for example, that at this spot we've got 1 black electron, well then we know that at this spot here we have to have 2 green electrons, because we know 2 and 1 have to equal 3. So if we go back to this here, we can see that in a parallel circuit, the logic is the exact opposite of a series circuit. Now what does a resistor actually look like? Well, what you're going to see is their supply teachers handed out this resistor sheet here. And what I've got here is I've got a photo of a resistor. Now what you're going to see on here is you're going to see 4 stripes. And I'm just going to draw it down here so I can exaggerate it a little bit. Okay? And you can include this on your note as well. Now you're going to have 4 stripes. Now how do you know which way to hold the resistor? Well, what you're going to do is you're going to look at the 4th stripe. This 4th stripe is going to be gold. So if you hold the resistor should have the gold piece on the right, like we have right here. You can see that that is gold. Now there are 3 other resistors that we're concerned about. So when we look at those, this is going to be value number 1. This is value number 2. And this one here is our power. So it's 10 to the power of number 3. What does that practically mean? Well, let's look at our photo here as an example. What we can see from here is we can see that the color for this first line here is brown. If you look at our second and third resistors here, these both look red to me. So in this particular case, we've got brown, red, red, gold. Well, what does that mean? We've got brown. If we look over here, we can see that brown is represented by a 1. We can see red is represented by a 2. So we know our resistor is going to be 12 times 10 to the power of, and since it's red again, it's going to be 2. So therefore, 10 to the power of 2 is 100. So 12 times 100, which is equal to 1200, which means the resistance of this resistor is 1200 ohms. So what I'm going to do now is you should take a look at this next resistor I have right here. Now I know the colors can be a little hard to read. So I'll tell you that on this resistor we have a red, we have a purple, we have a brown, and we have a gold. Hit pause on the video and try to figure out what the value of this resistor is. Okay, at this point I'll assume you have figured it out that our red is going to be 2, purple is going to be violet in this case, so 7, and then we've got brown, which is up here, so it's 27 times 10 to the power of 1, which makes that equal to 270 ohms. Yet again, hit pause on this video, and we can see, because I know it's hard to see the colors, is we can see that in this case we've got an orange, we have got an orange, we have a brown, and we have a gold. So go ahead and hit pause and see if you can figure it out. Okay, so for our third example there, our resistance is 330 ohms. One more example for you to try. And I would say in this case, our colors are going to be green, red, green, and brown. Go ahead and hit pause and try that question. In this particular case, if it's green, red, green, brown, that's going to make it 552 times 10 to the 5. So 52 times 100,000, which makes this have a resistance of 5.2 million ohms, or 5200000. So very, very high. So here's what's going to happen with your lab today. You're going to get this sheet from your supply teacher. And what I'm going to ask you to do is to go through the little box that the teacher will supply with a whole bunch of resistors in there. And I want your group of 3 to 4 people to find 4 resistors. Now you can pick out any ones you want. The first value cannot be under 200. So you want something small. So looking somewhere in the 2 to 500 range. R2 has to be a number that's larger than R1, but smaller than R3. So you're looking somewhere between 400 and 2,000. Now R3, you can either have identical or around R2. So give or take 100 ohms. So for example, if I found a 1200 ohm resistor here, I would want to find something, let's say, 1100 to 1300 ohms. And our last one is you want something that's larger than R2 and R3, but is less than 3,000. Now, once you've found that, what you're going to do is you're going to go through the rest of the lab. And you can see that you've got 5 examples right here. 5 labs for you to work through. So what you're going to do is you're going to take the value you found for R2, you're going to plug it in, and you're going to solve for the circuit. You're going to get very small numbers for your current. That's okay. That's what we would expect. For the second circuit, what you're going to have is you're going to use your R1 and R2 resistors, plug those values into these spots, and solve for the circuit. For circuit number 3, same thing, except you are working with resistor R2 and R4. On the back, these ones are a little bit trickier, because you can see if we look at circuit 4, it's neither a simple series nor a simple parallel. It's kind of a mix. So what do? You have to perform simplifications. Now, if you look at examples 4 and 5, these are the same examples that we did in our notes on our last class. Use those as a guide to see if you can solve the circuits. Now, once you've done all those things, you'll have already done this sheet with your calculations, and you can start to set up your data table. If you can set those 2 things up, you're set for today's class.